So welcome everyone. I had previously made bunch of videos where I solved problem using my this particular template file or boilerplate. So I know like there are beginners in competitive programming who initially don't really have their own template file, and they always write all the complete code from the scratch. So this is not really preferable if you are competing in a contest, right? And there are a bunch of things which you have to write repeatedly for same problems for different problems, right? So this is not really right way to do it. You should all have a template file, maybe with some certain features, certain use cases, but later on as you encounter other things, other repeated things in the various problem, you can just add these features into your particular boilerplate. So this is the plate which I used, and I made it over time. Like I have solved many problems, and whatever things I found redundant that I don't want to write again and again, like, so I added those features here. So I wanted to share this boilerplate with all you guys, and one by one I will just explain you like what all things are here and how they are used, right? So let's get started. So the very first thing is test cases. Of course, if you guys been solving some problem on Codeforces or CodeChef or any other platform, so you have encountered every time this test cases that you have to solve a bunch of things for a particular number of test cases. Let's say if you wanted to, let's just take a simple example. Let's say you are solving a problem where you are given two numbers A and B, and you just wanna print their sum. I'm just talking about an example, right? So you just want to print their sum, right? But you have to solve this particular thing for a number of test cases. Let's say if you want to solve this for a number of t test cases, right? You don't want to write this complete thing again and again. So you can simply have this particular thing in your template file where you can just start writing your code within this while loop, right? It will handle your test cases, right? You don't need to worry about it, and it will be very rare that you will be using this tc named variable anywhere, so there won't be any conflict, right? So the first thing was test cases. Now the second thing, which is very important and it is used in almost all the problems, that is vector, right? So I think if you guys been just exploring some problems, right, you have I definitely sure that you have come across a point where you are given an integer n, you want to take the input of it, and you want to take a input of array, you want to take a input of n numbers, right? So you always make your vector and you always take that input, right? So this thing also I found very redundant, right? You don't want to use this again and again, you don't want to write this same thing again and again, right? So I have made a simple feature for it, that is this input function, right? You just want to pass the reference to your vector and the length of your vector, right? And it will take your input for it, and as you're passing the reference for it, it will be showed here as well. So instead of writing this stuff, I can just replace it with input v comma n. So some guys might think that this is too much, right? We can just write those two lines, but okay, I take input of vector a lot of time. I don't want to write these two lines of for loop, so I prefer using this input function, because it happens with me a lot of times that you have to take the input of vector multiple time in a single problem, right? So you can simply use this input function. Just one thing, always remember that you have defined the size of the vector, otherwise it will give you runtime error, right? It expects that you have resized your vector to size n, right? So whenever you're passing your vector here, you just wanna make sure that you have sized it to n and whatever the length you want to take input for, right? So this was the feature one, I should say. So take the input of vector, right? And also if you wanna later in your code, if you want to take the input of some number in your vector, right? Let's say if I want to take the input of number 2, so pushback is used there, right? To take the number of any take the input of any number in your vector and any element in your vector, right? So there is one shortcut for it. You can use pb there, right? And we have defined pb here. So this is the define a character. It basically replace your this phrase with this particular phrase, right? So whenever I use PB, my compiler will consider it as pushback, right? And similarly we have PO that represent pop back to basically delete the last element of your vector, right? And other important thing which we have already defined, so I should just also tell you this is PB, right? It simply deletes your last element, right? And it simply takes the input of the element and put it to the last, right? And the other thing about vector which is very much important is the sort function. It's not only for vector, but it can also be used in other containers as well, you know, strings as well, and other thing as well, right? So what you do for sorting, you always do this, right? You have to write like this, right? It is very much redundant. Why are you writing all this? You can simply replace this same thing as the all feature. We have all here. So basically all represents, when you write all v, your compiler, I should comment this part, yeah. So whenever you will write all v, your compiler will replace it with this particular thing, right? And not only v, if you have some string s, you can just pass it like this, right? So you can just use it here. If you want to sort some function, if you want to sort some container, you can use this all feature to sort it, right? And this is like, these things are very much common, like competitive programmer use them in their boilerplate, right? And also, let's say if you want to sort it in decreasing order, you can just here pass greater, right? And whatever your data type is, whatever your element data type is, you can pass it here. So here you don't always need to write that v dot begin to v dot end, right? You can simply use this all feature, right? So these was the thing about vector. One more thing, if you want the iterator to the first element of your vector, you always use begin, right? So this is fine, and for the end you use this. But let's say you can also replace them, begin with be and second and end with en, right? So like this one is not very useful, even I don't use this one much, but yeah, just telling you for the information, right? So I think this was all about vector. And now the other thing, int. So it will happen with you a lot of time then when you're solving the problem. You will find that it overflows your int, right? You have to make all the things long. It is very much tedious. Even in some companies coding round, I have encountered that I'm writing my code, and this has happened with me more than 50% of time, that my code was correct, almost totally correct, but it fails because that int is overflowing, you know, and you have to rewrite all your int to the long. So this one is very much tedious. So here we have defined this. Where is it? Hashtag define int. It should be there. Yeah, sorry, I found it here. So here we have defined int as long. So wherever your compiler will encounter int, it will replace it with long. So you can just do your complete code with int as well, but your compiler will do that thing for you. It will replace your int with long. So this int will be treated as a long, and it won't overflow up to, of course, 10 raised to the power 18 and some little more than that. Yeah, so you can see that here it is showing define int long. So your compiler will treat it as long. But one thing I want to clarify, that whenever you are using this particular thing in your code, this particular line in your code, it will throw error if you haven't done this change. When you define main here, generally you guys write like this, right? It works. But now when you try to compile it, it will throw error. When I compile it, it should throw, yeah, it is throwing error at line number 79, because you cannot, the return type of main function cannot be a long, and your compiler is replacing int with a long, right? So we don't really want that. So that's why we have a signed here, right? the return type of your main can be a signed number, right? So just make sure to replace your int main with this signed so that you can use this line, right? This is very much useful, right? Using defining int to long, right? So yeah, this was about the int. And now one more thing. Now let's say if you are using pair somewhere, right? Auto p. So I generally use auto if there are, like, if I'm doing a dynamic initialization. So if you are writing like this 2 comma 3, you're making a pair, pair type number, right? So you always, like, you know that whenever we are binding two numbers together, you should either make them in a curly bracket, or we have defined one more feature here, you can use pm. So there is a function which is make pair to bind two numbers together, right? If you wanna make a pair type tuple q, there is this function to bind them together, right? So if you don't wanna use this long name make pair, because this pair type of data structure is used a lot of times in the problem where you have to bind two relevant information together. So instead of this make pair or this curly bracket, you can also use this. You can also use mp, and you just pass 2 comma 3, right? So whatever you find useful, you can use that, right? So this was about mp. And yeah, mp is defined by mp will be replaced by make pair, right? So yeah, this was nice. This was about make pair. Yeah, so after making the pair, you need to access their value, right? So generally what happens, for accessing the first value, you do like this p dot first, right? And for accessing the second value, you do like this, you write p dot second. So there is a shortcut for that. We have defined f for first and se for second. And again, if this seems redundant to you, like not useful to you, you can simply skip this. But as you will do more programming, I promise that you will find these things really interesting, because this will save you a lot of time. So simply you can access second value like p dot se, and the first value is p dot f, right? So this was about pairs and first and second. After that we have constants. So I just want to tell you a couple of constants. So if you guys are familiar with modular arithmetic, you might have seen that in some of the problems you are asked to return the answers with a modulo of this thing, 2 raised to the power 9 plus 7. So it's a prime number. You're asked to return the answer in the mod of this, because the answer can be too large to be stored in long even, right? So you have to use this particular number a lot of time. So instead of defining it again and again, we have made a global declaration of this by the name mod, right? So you can simply use it. This is like pretty much standard stuff. Everybody use this thing, right? So after that, similarly, we have infinity, because in some cases you need a very large number, which is not, you know, in your programming, like in your problem solving, you're not even achieving a number and you have to make some comparison. You can take this as an infinity, right? And you can even increase the value for it. I have kept it 10 raised to the power 18. And lastly, I have made this one. So why there's a reason of making this one? Because there is a very interesting thing I want to tell you. Let's say if you want to find power of 2 raised to the power, let's say 60. You want to find this, right? And for doing this, like we have very interesting bit operation, which is 1 left shift by whatever the number you want to raise the power of it. So consider 1 in the binary format, and you are doing the left shift operation. So how many times you will do? Let's say if you do it x times, this will result in 2 raised to the power x, right? So let's say if in any case you want to do it by 60, right, and you left it like this, and now you're doing your code, you will end up in an error, right? Because this will overflow, because by default C++ will consider this one as in int, and int cannot be like more than something 2 raised to the power 32 minus 1. I'm not sure about it, it was around that. So you cannot store a int value which is as large as 2 raised to the power 60. So you will end up in an error here, right? So to avoid this, you can instead replace this one by our this one, right? Because as we have told you previously, this one is considered as long because our int is long, right? So this was our constants, and there is a very interesting function after that I use. You know, in a lot of scenarios, you will end up replying yes or no in the output, right? So let's say if in some scenario you are making one flag true and you are doing some logic, and after that you wanna output, let's say if your flag is true, you wanna output yes, and if your flag is false, you wanna output no, right? So there's a very interesting stuff for this, like you don't need to write all this, you can simply use my tell me function, you can just pass your flag there, right? And it will handle your yes or no, right? You can just use this function, it's really quick, right? So it's basically here, if you pass your bool, it will give yes or no, you don't need to write it. So yeah, this was also one feature which I found really useful, because I don't like to write same code again and again for different problems, right? After that there are now there are several interesting functions which are really useful related to number theory concepts, which are so one is mod power. So I'm not sure you guys are aware about simple modular arithmetic or not, but in later I will be making videos on number theory as well. So like if you are aware about it, I'm just wanna tell you, let's say if you wanna find answer for something, let's say 23 raised to the power 132. So like this is a very large number. It cannot be stored in any format, like it cannot be stored in long, right? So in such cases, in the problem you are asked to return the answer in the mod, right? Instead of that, writing the logic for that, you can simply pass, let's say if you want to get the answer for a raised to the power b, if you want to find the answer for this thing, right? So you cannot directly do this, right? Because it's not a valid operation, because C++ will find the value for this, and this part will overflow before making this mod operation, right? So this is not a valid operation, and you have to get the answer for that as you calculate the value of a raised to the power b. So there is a concept in number theory which is called binary exponentiation, which can get the answer for this in logarithmic time complexity, right? So the code for that same thing is this, right? So this is basically the recursive code of the binary exponentiation. So this particular thing deserves a separate video. I don't want to explain this, but for the programmers who already know or who just want to use it before knowing the logic, it's totally fine. You can simply pass your a in the argument, then b in the second argument, and whatever the number you want to do mod by, you can just simply pass it there, right? So this will give you the result for this particular thing, right? And again I'm saying you cannot do like this in the C++. If you want to get the answer, and let's say you're doing like this, you will end up in an error, because this thing will overflow first, then it will do the mod, so which will result in a wrong answer, right? So you want to do the binary exponential here. Basically, as you calculate the power of a raised to the b, you will do mod on the way, and the thing, you don't need to write the code for that. You can simply use this function. So what you can do, you can get it like this. Yeah, so this was about mod power, right? And now there is one more thing in the modular arithmetic which is kind of tricky, that is getting the answer for the mod fraction. So similarly, I told you about a raised to the power b and getting the answer for this thing. You can use your mod power function, which is like this. You can pass a, b and mod, right? Similarly, you want to get the answer for p by q mod. So the trick is here, you cannot really get the answer for mod as simply as you can get for the multiplication and subtraction and addition. There is a really trick here when you end up getting the answer for the fractional value. Basically, if you want to get the answer for 1 by q, there is a trick for it, right? You have to use the Fermat-Little theorem for that, and that is also part of a number theory. So guys who knows or who don't knows, you can simply use this particular function which we have defined, that is mod frac. Yeah, you can just pass your p, you can just pass your q, and you can pass your mod. So the reason why I'm passing mod is that I have made this function for a generic mod value, because sometimes it might happen that mod value can be other than 10 raised to the power 9 plus 7. So I have made it for a generic mod value, so it is a good practice that you pass it here, right? And if you want to know the code for these two functions, it's present here. So here's the code for the mod POV, and it is written here for computing this, and here is the code for mod fraction, and it is written here, it is for computing this thing, right? You can simply you can simply find this in my boilerplate. So yeah, this was about mod power and mod fraction, and now it's almost done. And also I want to tell you about this. So I know some beginners might have seen this in like in many programmers boilerplate, but what does this thing mean? So basically it is for the fast input output. When you write this thing, your input output won't be bottleneck. So in simple word, I should say that let's say if you are taking input of 1000 test cases, and in each test cases you are taking the input for the array, right? And you are getting the answer for a particular test case. So what happens if you won't write these two lines? What it will do, it will take the input for each test case, and then it will generate the answer for that particular test case, and then it will give the answer for that. But if you write these two lines, what it will just take the complete input in a one go, and then it will give the complete output in a one go. Basically it holds the output until it receive whole input, then it will give the output. So basically there won't be context switching in between, right? So it takes whole input at once and it gives whole output at once, so input won't be bottleneck and your code will run faster. So this is very much important. I just want you to copy this line and put it in your template, and even you don't need to copy it because I will be providing this boilerplate at the end of this video, right? So yeah, this was about input bottlenecking, very much important line. And now one more thing which the beginners won't need, but as it is mentioned in the template file, I want to tell you. So here is this thing, you can comment it out for now. You can comment this particular line I would say, because by default it is commented in my boilerplate. So if you want to use it, just uncomment it. So basically this thing is for generating random number, right? And I will urge you guys to only use this particular function for random number, because other have really some bugs in them. So I won't explain how is this and what is this, because it will make my video too much longer. I just want to tell you, if you want to generate at some point, if you want to generate a random number, I'm sure that you won't be needing this if you are a beginner, but in very some tough problems, some higher level problems, there are things when you have to generate some random number, right? So you can simply use it like this. array, what was this, RNJ, yeah, and this will give you a random number, right? And let's say if you want to generate a random number only between 0 to 9, you can simply do like this. Yeah, so whatever the higher limit of your random number, let's say if you want to generate between 0 to 99, then you can simply do like this, right? So it is that simple. You just need to write this particular thing, and you just need to have this particular line in your code, the line number 23, this one, right? So yeah, this was about random number. And there are a couple of things which are commented in my boilerplate. This is related to PBDS, which is policy based data structure, and I'm very much sure this is like you won't be needing this in this stage of programming. This is something which I will cover in later videos of my channel, right? So I will assume that you guys just comment it or remove this, but for your knowledge, this PBDS stands for policy based data structure, right? It is basically made with some modification in the set structure, then it is made PBDS, and it has really good functionality, but I'm sure it is not needed for now, right? So there was PBDS, and other than that you can read some motivation code if you want. I would really appreciate that if you are stuck at any point in your problems and you are not able to solve that, just read this. Maybe you are going int overflow or array bound, maybe you are not checking, and maybe you are not thinking about DP, or just these are some random stuff which really helped me. So I would say just go through these, right, whenever you are stuck on a problem, right? And yeah, so this was about my boilerplate, and I will be providing this boilerplate in my description. You guys can check it. You can just use this. Now you have understood every functionality what is used here, right? And yeah, this was because we were using int here. Now we are using int, right? So yeah, also can you guys check my channel intro video. I have provided like what are my plans for the channel and what you will be finding here. So yeah, that was it. Thank you.